Hey there, I'm Alejandro, and this is
Osmani.
And today we're doing day 266 of me doing the Daily LeetCode Challenge. Let's say reach 1 year's worth of green contributions here on GitHub. So today's promise for April 8th, 2025. Without further ado,
Let's get started.
no,
I don't know.
let's get straight into it. Okay, today we get LeetCode Easy, problem 3396, minimum number of operations to make elements in an array distinct. And it seems like I saw this before, so I'm just gonna remove this. When did I solve this? December 21st, 2024. That means that might either be a Nico 150 problem or it's going to be one of the dailies. We can just check this quickly. What is this called? Minimum number of operations. Minimum number of operations. Okay, so this is not a Nico 150 problem. This might be a duplicate daily problem. Okay, so Mr. Osmani here has already read the problem and has been like geeking about wanting to tell me like thoughts about it. I told him no, not until I read it. So now I'll read it and then we can have a discussion, sir. Okay, you're given an integer array num, so you need to ensure that the elements in the array are distinct. To achieve this, you can perform the following operation any number of times. Remove three... You need to ensure that the elements in the array are distinct. To achieve this, you can perform the following operation any number of times. Remove 3 elements from the beginning of the array. If the array has fewer than 3 elements, remove all remaining elements. Note that an empty array is considered to have distinct elements. To the minimum number of operations, you need to make the elements in the array distinct. Oh, I see. So can we do n squared? This is LeetCode easy. Yeah, we can do n squared. So if we're lazy, maybe there's an O of n way of doing this. If we're lazy, we can do this in O of n squared. Basically, what we can do is def dp. We'll have an index I and an index j. And here we'll say, I guess, is there an O of 1 way to check if like... There's an O of nums. Yeah, if all the numbers are unique, then doing frequency hash maps will not make it O of 1. Yeah, I mean, worst case, this is just an easy. We can get on to board game night and just, there we go, right? So let's just do a DP function. I'll just put a cache decorator up in here. Actually, since Osmani is looking, we'll do this traditionally. We'll do self.nums is equal to nums. Here we'll have a memoization table, which will make it as a dictionary. And here we'll say if I, j is in self.memo, that means we've already solved this problem before. So we're going to return self.memo of I, j. When we return res at the very end, whatever res is, we're first going to say self.memo of I, j is equal to that result so that we remember it in case we ever come back to it again. Okay. So then here we're going to say return self.dp. dp of ij will be the minimum number of operations needed from index I to j. So in the beginning, it'll just be from 0 all the way up to the very last index in nums, right? Okay. Very simple. Now we're going to say, okay, first of all, if base case nums is already distinct, right? So if all the numbers in our current subarray is already distinct, we don't need to do any operations. We return 0 operations, it's already distinct, right? Okay, here I'm lazy, so I'll do if length of set of nums is equal to length of nums. Right, so here I'm going to convert it into a hash set with no duplicates, right? So I'm just being super lazy here, but we'll just, really, it's like, okay, we can do this a little bit better. We'll have a scene hash set, right? And so here it's like, for check if nums is already distinct, right? So for num in, for index in range I to j inclusive, we'll say num is equal to nums of index. If num in scene, then it's not distinct, right? So here we'll say is distinct is equal to true. Here we'll say is distinct is equal to false. And break, right? Otherwise, we'll do scene.add number. And here we'll say, okay, if it is indeed distinct, then return 0, right? So at any point, if we saw a duplicate number, we made it as distinct, false, and broke. Otherwise, we went through the entire thing. Is distinct. Oh, by the way, you're here. It's still distinct, and we return 0. No operations are needed, right? Otherwise, there's only 2 cases. Case 1 is we pop 3 elements from the left. Case 2 is pop 3 elements from the right. So the reason why I know this will work in DP is because we can do O of n squared total subproblems because there's n total indices where n is length of nums. So there's n possible values index I could be. There's n possible values
Wait, we
index J
can
could be.
remove from the left? It says remove,
Yeah, remove 3 elements from the beginning of the array. Oh, wait. Oh, I thought it was left or right. Wait, this is going to be even easier. Oh, wait, this is going to be even... I thought we could either pop from the left or the right, so that's why I was thinking DP. Yeah, this is even easier. Wait, so we can't pop from the right? Oh, okay, then we just go from the right and just go until we have a duplicate, right? And record that index. Yeah, this is actually even simpler. I thought we could break from the left or right. Here we would have to... Okay, my bad. This problem is even easier than I thought. My apologies, Osmani. I mean, it'll still work this way, right? It's just that here there's only one case, right? Res is equal to self.dp of I plus 3 comma j, right? You ignore index I plus 1, I plus 2, so I plus 3 is the next one, right? So something like this will still work. It's just like clearly super inefficient, right? Nums, yeah, so here we'll say nums is equal to self.nums, right? So something like this will work. Or maybe not. Oh, yeah, or is equal to 1 plus this. Now it shall work. Right, and here we can submit this. And this will definitely work just fine. It's just very inefficient, right? So yeah, completion streak 266 days, consistency is key, see you tomorrow. So yeah, but like, yeah, so there's no actual case of popping from the right. So we can actually optimize this way better. So here, what we can do is, yeah, we don't need any of this crap. Here we can just say, loop through nums in reverse order until you reach the first index that is a duplicate number. First index I that maps to a duplicate number. Then you know you must delete every index from 0
you have to
element
3 by 3 though,
nums
right?
from 0, yeah, to I, going 3
At a time.
deleting 3 elements at a time with a total of I minus 0 plus 1 equals I plus 1 elements. Hence, given this index I, minimum number of operations will simply be math.ceil of I plus 1 divided by 3. Okay. Okay. Sorry, I'm trying to include you in the video, but it's hard to code
okay.
sideways. There you go. I will code this way. Although now I'm scared of putting my feet there because Rob told us there's a spider in here. No. Okay. Maybe I go like this. Yeah. Okay. So here, yeah, we'll do for I in range length of nums minus 1, -1, -1. Here we'll say num is equal to nums of I. Here we'll have a scene hash set. If num in scene, then break. Otherwise, scene.add num. Right? So I will be index is equal to none. Right, here we'll just say index is equal to I. This. Return 0 if index is none, right? If we never update it, that means there's no duplicates. Otherwise, we'll do math.ceil of I plus 1 divided by 3. Something like this. Yeah, that's accepted. Let's submit. And there we go. Bada bing, bada boom. For MS, beats 51.86% of submissions. Yeah, maybe there's a better way of, like, you know, maybe it's like if I do something like for num in reversed nums, and then I could count, like, you know, indexing like this is very inefficient. for I comma num in enumerate reversed nums. Does that work? Is equal to length of nums minus 1 minus I probably. Or minus I, just in fact, if anything. Yeah, okay, I'd have to get the math a little correct. Okay, worst case is just like, yeah, indexing is a little bit inefficient, but it's still O of 1, so I'm not going to make it a huge deal, right? We can just submit it as it is, and there we go. We have a probably optimal solution. So yeah, 3ms, okay, if we make some of the O of 1 stuff better, maybe we get 0ms, but this is good enough as it is. So nevertheless, as always, in all my videos, I do a quick recap if I suppose solve the problem. So for this one, I actually misread this problem in that essentially you want to make nums, all the elements in nums distinct, and you're only allowed to remove 3 elements from the beginning of the array as an operation, and you want to do the minimum number of operations. I misread this problem at the very beginning in that I thought you could either delete 3 from the left or delete 3 from the right. So I immediately thought DP, where it's like you have 2 possible cases, delete from the left or delete from the right. Turns out you only need to delete from the left. So this problem is actually a lot simpler, and you don't need DP because there's only one operation you can do, which is delete from the left. There is no choice. So here you can kind of, I guess if anything, this is quote unquote greedy, but whatever. Essentially you want to see, okay, if I go from nums from the right, what is going to be the first index where it'll cause a duplicate element to be there, right? Because that would be the very first index that causes things to not be distinct inside of nums, right? And so essentially what I'm going to do is I'm going to go through nums in reverse order until I find the first index that would give me a duplicate. And I'm like, aha, okay, this index and any index before it must be deleted because the one at index I that I found must be deleted because it's duplicate. Since I can only delete from the left, I must delete from the left until I delete this very character, and the rest of the elements will no longer be duplicates. They'll all be distinct, right? So if I find this magical index I, that is the very first index I from the right of nums, that essentially causes therefore there to be a duplicate, I know that I must delete index I and everything before it, right? So how many elements are there in total from index 0 to I? Well, there's going to be I minus 0 plus 1 is equal to I plus 1 total elements. And so how many operations do you need to do? Well, you delete 3 elements at a time, so it'll be the ceiling of I plus 1 divided by 3, right? If it takes 2.33 operations, then you need two operations and another one to get rid of index I, and unfortunately, like, 2 more numbers and so on. So that's why we do math.ceil, right? But otherwise, that's literally my code. I have a hash set here to check whenever I find a duplicate. Here I have index is equal to none initially, and we're going to loop through from the right of nums to the left. Num is equal to nums of I. If that number isn't seen, that is the very first time we see a duplicate. So let's set that index value to I and break out the for loop. Otherwise, we'll just add that number to seen to keep on going until we find the very first duplicate, right? If index is none, that means we never found a duplicate. That means that all of nums is already distinct. In that case, we return 0. Otherwise, if index is not none, that means it's some index that was like, the first duplicate from the right. So we need to delete every single index that is either I or smaller than I, right? Because we can only delete from the left, which will be math.ceil of I plus 1 over 3 total operations. And there we go, bada bing, bada boom. We have a nice and reasonably efficient solution. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, in any way, shape, or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So until then,
Bye-bye.
no.
Oh, shoot.
Ciao, ciao.
Ciao, ciao.
Ciao, ciao, my friend.
Bye-bye.
Bye-bye.